Hi, I'm Akshay. I've been writing Go for about 10 years now at little startups and big companies like Uber and Microsoft. And in all of that time, every Kafka deployment that I have seen is an unmitigated tire fire. These days, I work at Buff, and in the next 6 minutes, we're going to explore a better way to build data pipelines with protocol buffers. Now, some of you probably know what Kafka is, but if you're not sure, it is the world's most popular message queue. And in Kafka terms, producers send data to Kafka, consumers read data from Kafka, and topics organize your data into collections. You can think of a topic a lot like an append-only log file. It's a simple model. And so workflows that use Kafka take a predictable shape. You have a producer that writes the data to Kafka, and a series of stepwise transformations that read data from one topic, mutate it in some way, and write it to a new topic. And at the end, all of the data gets shipped out to some analytic storage. That might be a Parquet file in S3, it might be BigQuery, it might be Snowflake. But it's somewhere where you can run queries and gather insight. To take an example, let's imagine that we own the user service for our company, and users show up every so often and they update their profiles. Every time they update their profile, our Go service is going to write the profile data to Kafka. Then a Python bit of code is going to run some machine learning magic, and it's going to predict the likelihood that that user is going to cancel their account in the next month. It's going to write that data back to Kafka, and then some bit of Java code is going to show up, and it's going to expunge any sensitive data from the profile before we ship it out to BigQuery for our analysts to work on. And using this data, the analysts are going to make some financial projections, and they're going to drive our marketing strategy. From Kafka's perspective, this is all well and good, but we are not in Postgres. There's no schema here. From Kafka's perspective, all of this is just bytes. And our code has to bring structure to the data. And so you might first reach for JSON. This is nice and simple, right? Our profiles are, for argument's sake, just an ID and a name. And then the Python code grabs it and it inserts this likelihood floating point prediction. Our Java code deletes the name, and we end up with this nice clean row in Bigtable. But of course, underneath this, there's a lot of complexity, because all of these data shapes are implicit. So for this poor Python programmer to write their machine learning code, they need to understand what is in the profile topic. And to do that, they need to go spelunking around in our Go code base and find whatever struct we use to define this message. And they need to keep coming back and doing this every time we add new data or we want to touch the business logic. Not only is this a pain in the neck, it is really, really error-prone. So imagine that the poor Java programmer comes in and misspells likelihood. Now, all the work that we did to make this prediction of how likely I am to cancel gets dropped on the floor. Instead, the likelihood becomes a 0, and that 0 gets propagated up into BigQuery, where now our analysts are freaking out, our financial projections are overly rosy, and the world has gone to hell. Instead, what we need here is an explicit contract. And we're going to write that using a schema language. Here's what our profile data looks like in protocol buffers. Now, this looks a little bit weird, but it's semantically very similar to a Go struct. We have a struct with a name and a couple of fields. I have an integer ID, a string name, and a floating point cancellation likelihood. And one thing that you'll note is that there is a structured, type-safe, machine-readable annotation that indicates that the name is sensitive. It needs to be redacted or stripped out before this data makes its way to BigQuery. From this schema, I'm going to generate consistent and correct code in Go, in Python, and in Java. And that code is going to read and write a really efficient binary format. So this gets me out of the drudgery of spelunking around and copying around data structures, and it saves space in my Kafka cluster. But the best news for us as Go programmers is that we can use these same data shapes and schemas to define our gRPC APIs. And now the product engineers, the data engineers, and the analysts are speaking the same language. Once we have this, we are most of the way through our problems. But there are a couple of gaps left. And in the Kafka ecosystem, we plug those gaps with a schema registry. Why bother? Well, first, the registry gives you a canonical source of truth for what the schema ought to be. And this is important because usually the producer has one copy of the schema and the consumer has another copy. And if they ever disagree, you want a clear place to go that breaks ties. By gathering all the schemas in one place, you also have an easy way to do discovery and find documentation. So if your analyst is wondering what all this profile data means and how to interpret it, they have a place to go search and read the documentation about the semantics of each field. Registries are also the natural place to do policy enforcement. Now, that's usually kind of a dirty word. Like, you think of Jira and required workflows and the state transitions that are allowed and not allowed. But basically, this is your last-ditch effort to save yourselves from outages. Almost every organization is going to want to require that as schemas change, they stay backward compatible, so you're not breaking the workflows you already have. And you might want to enforce additional policies, like requiring that fields be annotated for whether they're safe for the data warehouse or not. And the last thing you get is runtime schema access for reflection. What that buys you is it buys you the ability to write really, really generic, reusable Kafka processing logic. In our example, that Java code that's stripping out sensitive data, that would use reflection. And that means that I could write it once, deploy it once, and it would work for any Protobuf message in any Kafka topic, and I would never need to think about it again. There's a standard for what these APIs look like in Kafka. And Buff, Confluent, and Redpanda all implement the same APIs. So if there's one thing you take away from this talk, it should be this. Schemas help everyone. High-quality data leads to high-quality insights. If you're curious about any of this, come talk to us at the Buff booth later today. Thank you for your time.